Hello everyone, welcome to our mathcast today. The intended audience is grade 4. The content or learning objective is to go over two-dimensional symmetry, Module 4, Topic D, created by Mackenzie Whitmore. How about we go over some vocabulary? So, since it's about symmetry, let's learn what symmetry is. Symmetry is the property of a shape that can be folded so that two halves match exactly. And as you can see up here, you have a triangle, and if you fold that over the line, it'll match exactly. The next vocab word is line of symmetry, which is the reflection symmetry, line symmetry, mirror image symmetry, is basically symmetry with respect to reflection. Next we have triangle, a two-dimensional flat shape with three sides, as shown up here. Now we have scalene triangle, a triangle whose sides are all different lengths. Equilateral triangle, a triangle whose sides are all the same length. And isosceles triangle, a triangle with exactly two congruent sides. So, for example 1, I broke it up into two parts. So in the first half, you have four shapes shown here. So for the first one, I will show you their line of symmetry and how they would fold over the line. So this is how you make a line of symmetry. Now if you fold that first part over, it would look exactly like this part. Now down here, this could have a few lines of symmetry. And it would end up looking the same either way. For example 3, we have a circle, same kind of feature. Sorry, my lines are a little crooked, but you get the point. And a cone can only have one type of line of symmetry. Now, over on the second part, we're going to draw the missing piece. Now, pause the video and try it on your own. So, to draw the missing piece, you just simply draw the other side. So for this heart, it would look something like that. For the square, for the circle, and the triangle's a little off, but that's eventually what it would look like if you were to draw the missing piece. Now, for example 2, this will be quite a long one. I'm going to go over each triangle shown here and why they are called each name. So, for the first one, we have the equilateral triangle. Now, why do you think this is called the equilateral triangle? Well, because each side is equal to each other. That is why it's called equilateral triangle. Now, over here, we have the isosceles triangle. Now, it's called the isosceles triangle because it has two sides of equal length, not three. Next is the right triangle, as you can see here. And it is called the right triangle because the one side is 90 degrees. Down here we have the acute triangle. It is called the acute triangle because three sides are different lengths. And lastly, we have the obtuse triangle, where one side is not equal to each side. It's larger in length. So, now that we know all these triangles, I will show you how you fold each of them with symmetry. So, for the equilateral triangle, if you were to fold this out, bring this side over to this side, it would be equal. Same with the isosceles triangle. Fold it over here, would match. We're gonna come on down to here. Now the acute triangle is a little tricky because not all of the sides are the same. So, I believe it would be a little hard to make this symmetrical because not all sides are the same. You could try, but this side is bigger than this side, so it would not be symmetrical. For the right triangle, you could try it like this, fold it that way, and it would be symmetrical either way. And for the obtuse triangle, you could only fold it probably one way, because if you were to go this way, it wouldn't match on this side. So that is how each triangle in this example will be folded with symmetry. Thank you for watching my Mathcast. Down below are the resources I used to make this. Thank you.